Hello, everyone, and happy Monday. I hope you had a good weekend and are ready for another week of chemistry, uh, talking about the mole. Um, Today, we are continuing our conversation and lecture on converting mass to moles. Um, you can follow along with your same notes from last week. Just continue on from where we left off. Remember that we skipped percent composition, and we'll be catching that up later on this week. Once you're ready, we will continue on. First, a little bit of a review chart of the different types of particles. Remember that atoms are the smallest part of an element and that they're made up of protons, neutrons, and electrons. Some examples of atoms include aluminum, beryllium, that's Be, carbon, nitrogen, but basically any element on the periodic table by itself is made up of an atom. A molecule is when you have two or more atoms chemically bonded together. So that's when we get into our different compounds like sodium chloride here, water, H2O, this is sulfuric acid, and oxygen. Oxygen always exists bound to itself in groups of two. Those are called diatomic molecules. Um, but those are all molecules, which means there are two or more atoms that are bonded together. When we convert from mass to moles, we talked about how to convert grams to moles last week, both on Wednesday and Thursday. You did some of that. Um, but we also can convert from a mole to the number of particles, which is usually either talking about atoms or molecules. But we can convert between the two. Um, and just like we've been talking about for a week now, a mole of a substance is equal to 6.02 times 10 to the 23rd particles of that substance. Whether it be donuts or jelly beans, like we talked about last week, or atoms, molecules, a mole is 6.02 times 10 to the 23rd of whatever that is. Um, when we want to convert between the two, remember like last week when we converted between grams and moles, if we want to convert between moles and particles, this is the conversion factor that we will use. 1 mole equals 6.02 times 10 to the 23rd particles. Remember last week with the grams, it was we got the conversion factor from the periodic table. When we convert to particles, it doesn't matter what the thing is, this will always be the conversion factor that we will use, regardless, when you're going between moles and particles. So let's do a quick example of this. It says how many grams are in 2.34 moles of sodium chloride? So let's try this example, which says how many molecules are in 2.34 moles of sodium chloride. So let me grab my little pen here. Um, so I'm starting with 2.34. Promise by the end of the semester I'll get good at this. Moles of sodium chloride. And since I'm going from moles to particles, I'm going to multiply that times 6.02 times 10 to the 23rd. That's an exponent. So when I multiply these two things together, 2.34 moles times 6.02 times 10 to the 23rd, I'm getting my calculator together here, sorry. Let me just talk while I do that. The reason that you multiply is because we're going from moles to particles. If we were going from molecules to moles, we would divide. So I got 2.34 times 6.02 times 10 to the 23rd, which gives me 1.41 times 10 to the 24th. As you're working through this, if you don't remember your rules on scientific notation, go back and watch that video, or look it up, or ask me. Um, but this is how you do that conversion. 2.34 times 6.02 times 10 to the 23rd, which means in 2.34 moles of sodium chloride, there's 1.41 times 10 to the 24th particles. So that is an extremely large number of particles. Let's see, let's try the next example here. Let me erase. All right, so here's another example going the other direction. It says, how many moles are in 8.23 times 10 to the 32 molecules of water? So now because I'm converting molecules to moles, I know I need to divide. So I'm going to take 8.23 times 10 to the 32 divided by, and the conversion factor number is always the same, 6.02 times 10 to the 23rd. That will tell me how many moles is in 8.23 times 10 to the 23rd molecule. So 8.23 times 10 to the 32 divided by 6.02 times 10 to the 23, which gives me 1.36 times 10 to the 9. Okay, so I got 1.36 times 10 to the 9, which is about a million. So there's a million moles of water in that many molecules. So when you're going from moles to molecules, you multiply. But here, when you're going from molecules to moles, you divide. I'll try to remember to get you guys a sheet that has all that on it. Remind me if I don't remember myself. So in your notes are some practice problems like this. I need you to work them for your homework tonight and bring them to class tomorrow when we have our Zoom class. Okay? So they look like this. I'll give you some hint. Remember when you're going from molecules to moles, for this one you'll divide. For this one you'll multiply because you're starting with moles and going to atoms. And this one I'll let you work out on your own. These are in your notes. Work them through in your notes. Bring them to Zoom class tomorrow because I'm going to ask you about them when we get there. Okay, there's the fourth one. But make sure you work on those. Okay. So, aside from converting from grams to moles and from moles to particles, we can also convert from volume to moles. Remember on Thursday I showed you that mole box that had a volume of gas in it, of air in it. It had 1 mole of air in it. Well, we can also convert from volume to moles. So when we have a gas or a liquid, let's just stick with gas. We won't get into liquid. But when we have a gas, we can convert what volume it is to equal how many moles it is. So a little definition to start out with. STP, you'll see that in a lot of these problems. It stands for standard temperature and pressure. Temperature is different all over the world. Like probably the temperature here at school where I am right now is totally different from the temperature at your house. It's at least a couple degrees off. I know it's always about 3 degrees warmer at my house in Carolina Beach than it is here at school. And pressure, air pressure is different. We're basically at sea level, so our pressure is a lot higher than those people that live up in the mountains. They have a lower air pressure. We'll talk about that in a lot more detail when we get to talking about gases. But for now, you need to know that standard temperature and pressure is always abbreviated STP. It's real important, like it says here in this paragraph, that we are specific about that because it will make a difference in the problems that we do. So that is really important. Standard temperature is equal to 0 degrees Celsius. So anytime you see standard temperature, that's what it is. And standard pressure is 1 atmosphere. We'll pick those because they're basically easy to do the math with, right? So it's a good starting point. It's a good standard for doing these problems. And like it says there, I'll move up so you can read that. Hopefully that, yes. All the problems that we will talk about in this section are at standard temperature and pressure. Later on, we'll get into changing that. But for now, you just need to know what it is and that you don't really need to worry about it a whole lot. But it's important. All right. So the conversion factor for converting volume to moles is in liters, but 1 mole of gas at standard temperature and pressure is always equal to 22.4 liters. It doesn't matter what the gas is, just like with the particles. 1 mole of gas is 22.4 liters. So that makes this our conversion factor. 22.4 liters equals 1 mole. So now I can convert between the two, just like we did with grams on Thursday, and just like we did with particles a minute ago. So let's see. Here's an example problem. What volume will 5.99 moles of oxygen gas occupy at standard temperature and pressure? Okay. So because we're starting with moles and going to volume, we know we're going to multiply, just like with the particles. So we have 5.99 moles. And we're going to multiply that by 22.4 liters in 1 mole. Okay. So when we do that multiplication problem, 5.99 times 22.4, we get 134.2. 134.2 liters of oxygen. O2, I'll call it. So 134.2 liters of oxygen is 5.99 moles. So let's try another example here. Oh, let me erase my first example. All right, so this time we're going the other way. We know we have a gas that is taking up 0.176 liters of space. And we need to know how many moles that is. Okay, so this time, because we're starting with liters, we know we need to divide. So we have 0.176 liters divided by 22.4 liters, When we do that, it will tell us how many moles that we have. 0.176 divided by 22.4, 0.008. So I'm actually going to write this in scientific notation because that's a lot of zeros. So it's 8. Actually, let's erase that because I rounded. I should not. It is 7.86 times 10 to the negative 3 moles. When you do this on your calculator, you'll see it'll say 0.00786. But because of significant figures, I know I need 3 significant figures. And if I wrote it this way, that would be just 0.008. So this is a little bit more accurate. We always like to write in scientific notation whenever possible. So don't write it this way, but write it this way. 7.86 times 10 to the negative third moles if a gas occupies 0.176 liters of space. So again, you're just using that conversion factor. You divide when they're the same, you multiply when they're different, and that will get you your converting. Again, you've got some practice problems of these in your notes. Do them before class tomorrow. That is your homework today. There were 4, I think, previously, and there are 8 right here. So you have a total of 12 problems to work out in your notes to bring to class tomorrow. The first 2 look like this at this point, and then there are 6 more that combine everything. So make sure this is your homework. I'm going to need to see it tomorrow when you come to class. Okay, so make sure you get that done. Super, super important. Okay. A couple quick announcements. Remember, resume tomorrow. That's Tuesday at 9:30 a.m. I will send you the link. And like I've said now a couple of times, do those practice problems. Bring them to class. And I will see you all tomorrow.